Project Tutorial 19 Multiple Ultrasonic Sensor Touch LED Dispenser for Food Items. As according to the title, it is clear that this system is used to dispense food items with touchless sensor system. In my previous tutorials, I have made videos on automatic sanitizer dispensers or touchless sanitizer dispensers. So you can use this project tutorial either as a touch LED dispensing system for a sanitizer or touch LED dispensing system for food items. So the extra feature which I have used in this tutorial is multiple channels, means more than one channels, and two more features I have included, which are time adjustment. As you can see that time adjustment and distance adjustment. That means you can adjust time according to your need and distance according to your need. So beginning our project, you are watching Tronics Technical Project with Sushil Yadav. Okay, first of all we will gather all the components which is required for our project. First of all, Arduino Uno. After that, a 12 volt to 24 volt DC, 5 ampere to 10 ampere battery. It's an optional. You can also use any adapter or SMPS up to rating 12 to 24 volt under 5 to 10 ampere. We are using, because 5 to 10 ampere, because we use 3 solenoid valve, or the system is little bit more complicated, more number of components are added. That's why it will consume more current. That's why we have to use 5 to 10 ampere a battery or SMPS. Okay, after that we have to use an LM2596, a buck converter. Buck converter is in step down DC converter, means it will step down from 12 volt to minimum up to 1.3 volt. You can see my previous tutorials. I have taught you how to know about LM2596 buck converter. Okay, so using this buck converter we can we have to step down our DC from 12 volt or 24 volt to 5 volt, because our Arduino Uno runs on 5 volt. Okay, moving on. We have used here a distance adjustment port 1K to 5K. 1K to 5K. Okay, in LM2596, as you can see that input negative, input positive, output positive and output negative. Output should be 5 volt. Okay, moving on. We have used two system here, two ports. For a distance adjustment and for a timer adjustment. As you can see that in ports there are 3 pins. You can connect first pin with positive 5 volt, last pin with ground, and middle pin for analog output. So this timer adjustment pin should connect with A0 of Arduino Uno. I will explain you further. I will explain you later the circuit connection, wiring connection. Okay, so this for A1, is for A0, and this for A1. So main thing is we have to use a potentiometer up to a range of 1K, maximum to maximum 1K to 5K. If in local market 1K is not available, then you can use 2K or 5K. But it is recommended that you should use a 1K, because 1K is equal to 1000 ohm, and our analog value is 1024, means 1024 units. So if we will use 1K, means 1000 ohm potentiometer, then for calibration it will be very best for calibration. Okay, moving on. We have to use a MOSFET for turning on and off our solenoids. Okay, MOSFET should be IRF540. You can use other also, but it's a standard MOSFETs which we can use, or which is easily available in the market. You have to use a solenoid valve. This is a 24 volt solenoid valve. So whatever battery or SMPS you are using, it should be of 24 volt. Okay, moving on, you have to use 3 ultrasonic sensors, and these are the pin configuration of the ultrasonic sensors. Okay, these are the pin configurations. VCC, T means trigger, E means echo, and ground. Likewise, it is mentioned in others also. Okay, moving on. An LED for indication. LED for on and off indication. 1K resistors for gate. For providing gate signal to the MOSFET, you have to use 1K resistor for a safety purpose. 33K resistor, 33K resistor to connect in between gate and your source. And you have to use IN4007 diode. This is a reverse polarity. This is a back EMF protection diode, which will protect your whole system from back EMF generated by the coil of the solenoid valve. Okay, moving on. As you can see that without this and positive, you can identify the positive and negative portion of this diode by a line. If you see a mark here, that means it's for a negative side or cathode side, and if you doesn't see any mark or a line, that means it's a positive or anode side. Okay, first of all, you have to connect the ground with the input negative of buck converter and the positive of battery or SMPS with the input positive of LM2596. You have to adjust the output of buck converter by varying this potentiometer. This blue color component here is a potentiometer. You have to rotate this potentiometer to step down from 24 volt to 5 volt. So for more information, see my previous videos on LM2596. Okay, after that, connect. This is an output negative. Connect the output negative with the ground of Arduino Uno, and output positive means 5 volt with the V input of Arduino Uno. Okay, so you can see that V input of Arduino Uno. Okay, after that, connect the positive output with the first pin of 1K potentiometer. Moving on, connect the third pin with the output negative of buck converter, and also the third pin of distance adjustment potentiometer with the negative of buck converter. Moving on, connect the A0 of timer adjustment potentiometer with the A0 of Arduino Uno board, and the A1 of distance adjustment port with the A1 of Arduino Uno board. Okay, moving on, connect the wirings like 1K resistor with LED. This side is for anode, means positive section. Okay, so the shorter pin is cathode and the longer pin is anode. Okay, moving on, just connect the wirings as according to this circuit diagram. Just connect all the resistors with each other and connect it with the positive input positive. Okay, input positive of LM2596. After that, from positive 5 volt, from the positive 5 volt of LM2596 buck converter, connect all the positives of ultrasonic sensor to the positive of buck converter, LM2596 buck converter. Okay, moving on, connect the ground. Connect all the grounds of ultrasonic ultrasonic sensor with the ground of LM2596. Okay, you have connected at the third pin, that means it is already connected here, means it is connected at the output negative of LM2596. Okay, now we have connected all the ground of ultrasonic pin with ground of LM2596. Moving on, these resistors are for gate. These resistors are used to activate the MOSFETs. So these are the gate resistors. Okay, so you have to, these are the output pins. We have used 8, 9, 10 pins of Arduino Uno as the output pin. So you have to connect the 8 pin with the first of 1K resistor. That means 8 is for IRF540 MOSFET or for first solenoid valve. Okay, likewise, moving on. Likewise, you have to connect the second resistor or second MOSFET gate resistor with pin number 9 of Arduino Uno board, and likewise connect the third resistor of third MOSFET with the pin number 10 of Arduino Uno board. Okay, moving on. Connect the 33K with gate and source. Here the first one is gate, middle one is drain, and third one is source. Okay, always remember, first pin is gate, drain and source. So we are connecting the one pin of resistor, 33K resistor, with the gate of every MOSFET. Okay, moving on. Connect the other pin of resistor, 33K resistor, with the gate, drain, source with the source of every MOSFET. Okay, as you have seen that. Moving on. The middle one is drain, means it is an output. It means it will send a negative signal or negative output when a gate signal is received. So whenever it will receive a gate signal, it will send a negative signal or negative output to our LEDs to show that our system is activated. So likewise, connect the drain with the anode of LED, first LED. Likewise, connect the drain of second MOSFET with the second LED, and likewise connect the drain of third MOSFET with the third LED. Okay, moving on. For safety purpose, connect the cathode of IN4007 diode with one of the wire of solenoid valve. Solenoid valve doesn't have any polarity because it consists only a coil, so you can connect it anywhere. Moving on, connect like this circuit diagram. Okay, and after that you have to connect the drain of MOSFET. I'm just zooming it, see it. You have to connect the drain of first MOSFET with the cathode of diode or cathode of your system. Connect it with the cathode of your IN4007 diode. Likewise, connect all the diodes in this manner. As you can see that, connect this in the cathode of second diode and connect the third MOSFET drain with the cathode of third diode. Okay, moving on. Connect the other pin or other wire of solenoid valve with the positive input of LM2596, or you can also say that connect it with the positive directly with the battery. Okay, so the other pin, always remember that the remaining or other pin of the solenoid valve connect it with directly with the 12 volt or 24 volt of DC battery or DC source. Likewise, connects all the pins, all the other wires with the positive 12 or 24 volt. Okay, we have connected here. Now moving on, connect all the T means trigger, E means echo. Connect all the trigger and echo wires with our Arduino Uno board. So here is the you have to see it clearly that we have used 2, 3, 4, 5 and 6, 7. 2 is trigger and 3 is echo for ultrasonic 1. 4 is trigger and 5 is echo for ultrasonic 2, 6 is trigger and 7 is echo for ultrasonic 3. So connect like this. Okay, see it very carefully. I am connecting it. So as according to this wirings, you have seen that we have used 2, 3, 5, 6 and 7 Arduino pin for our ultrasonic 1, 2 and 3. Okay, so after that you have to connect a pipe with your solenoid valve. So what will happen if we will put any food item here, as see it clearly, what will happen if we put any food item below our system, then our ultrasonic sensor will sense any object and it will send a signal to the LED that our system is activated, and after that within a speed of light, means within a microseconds, what will happen, our dispenser, our solenoid valve will open and dispense a food item in our food item which we are holding in our hand. Okay, moving on. Likewise, if we will put any food item below the other ultrasonic sensor, then it will do like same like the first one. It will glow and indicate that second system is also activated, and it will dispense a food item in the second system. Likewise, when we will put our hand below the third ultrasonic sensor, it will indicate that our third system is activated and dispense the food item in our third system. So we will understand it clearly in this second format, that in a very simple format, that we will take a container in which we have to put our food item here, and after that make a pipe section for 3 systems. Okay, put your solenoid valves here. After that, put an other pipes for dispensing and ultrasonic sensors for sensing. Okay, first one potentiometer is for timer adjustment, second one is for distance adjustment, and we will assemble all our circuits in a control box. Okay, after that, timer adjustment will give signal to our control box. Distance adjustment also gives signal to our control box. By that we can adjust the time limit or timing, means at how much delay our solenoid valve should open. So it is a delay control of our solenoid valve. And distance adjustment is the distance, by means we can control our ultrasonic sensing distance sensing. Okay, moving on, our ultrasonic sensor will send a signal to our control box. By that it will send a signal to our solenoid valve to open or close. Likewise, the second system will also send control box will send the signal to the second solenoid valve. Likewise, vice versa, third system will also send a signal to the control box, and our program will read and send the signal to our third solenoid valve. The program of this system, you can download it from the link below. Okay, just see in the below content, below description, you can find a link. From there you can download the program, the Arduino code from there. Okay, so what if we will use food items here, like cold drinks, juice, pani puri, and various according to our imaginations, what we can use for our touchless dispenser system. Okay, so whenever we will put our hand below this ultrasonic sensor, it will sense, and what will happen, the food item will dispense and fill in these pipes. Okay, but it will not dispense because a control box haven't given signal to the solenoid valve to open. Whenever we will put our hand below any of this ultrasonic sensor, then that sensor will send a signal to our control box, and only the solenoid valve near to that ultrasonic sensor will open. Okay, so what will open? What will it do? It will dispense an amount of food liquid to our food item. Likewise, we can dispense cold drinks also, and likewise we can dispense anything which you want. Okay, so thank you for watching.